Now see this kind of waveform, how can we solve it? And in the x-axis we are having theta, and in the y-axis we are having, right? So we need to calculate the same thing, that is RMS and average. Okay, so again we'll use the same formula which we have used in this case. See, again we have to they see that whether it's in symmetry or asymmetry. Okay, so if it is in symmetry, then in that case we know we need to calculate V average. V average is how much? Base length is how much? It varies from 0 to pi. So base length is how much? That is pi minus z. Correct? This is the formula now. Now again we have to integrate. It vary from 0 to pi. Correct? So it will vary from 0 to pi and v d theta. Correct? Why it is d theta? Because it's on x-axis we take theta. As you know that v is equal to, we are having standard equation that v is equal to vm sine theta. So we can substitute the value of vm sine theta, then we'll get 0 to pi vm sine theta d theta divided by pi. Correct? If we put the value of this, if we solve it by the integration, then we'll get the same thing, that is 2m divided by pi. Pm we know, or they'll give you, then we'll get it. Okay, next one is the vrms. Again in the vrms we'll use the same formula, that is root. Okay, and its limit vary from 0 to pi. Correct? Now there is a difference in the base length, right? How much is the base length in this case? If we'll take it, base length is how much? That is 2 pi minus. If I told you there is difference only in the base length. If we'll take this base length, that would be pi minus 0, and if there is this base length, then in that case that would be pi minus 0. Got it? Now we need to substitute m sine theta d theta. Now you can solve it. If you will have any problem, then you can let me know.